Hello everybody, it's Miss Fincham and we'll be continuing Unit 1 by covering the topic 4.8 Geography and Climate. Thank you to Jordan Smeeds for the slides and notes we use in class. In this section we will be looking at how geography can affect Earth's climate, and we'll be focusing on how regional factors like wind patterns, mountain ranges, and large bodies of water can influence climate. This topic draws a lot from earlier topics in this video, so you will definitely want to make sure you've seen topic 4.5, which is global wind patterns, and topic 4.7, which is solar radiation. And you can check both of those out in the links on the notes page. Our objective today is to describe how Earth's geography affects weather and climate, and the essential knowledge we need in order to do that is that weather and climate are affected by the sun's energy, but also by geographic features like mountains and ocean temperature. We will be looking specifically at an effect known as the rain shadow effect and how that impacts weather on either side of the mountain. Our science skill for the day is to explain relationships between characteristics of environmental concepts represented visually. To review, climate is largely determined by insolation or the intensity of incoming solar radiation. As a general rule, the equator gets the most direct sunlight, so it's the warmest, which drives air to rise at the equator, which causes precipitation to be highest there as well. Then as the air sinks back down from the Hadley cell at 30 degrees north and south, that leads to the formation of very dry conditions and deserts form. We also have this general rule of thumb that as we move further away from the equator, temperature gets colder as insolation is spread out over a larger area due to the Earth's curvature, and as it passes through more atmosphere before reaching land. However, those are kind of broad generalizations about climate, so today we'll look much more precisely at some other factors that determine climate, especially regional climates. The first is the location of mountains, which can disrupt the movement of wind and produce something called the rain shadow effect. And then we also have the location and temperature of oceans, which will generally add moisture to the air of nearby land and can moderate or stabilize the temperature, since water absorbs heat from the land when it's really hot and also releases heat to the land when it's really cold. Now we'll talk about the effect that mountains can have on nearby weather patterns. So the rain shadow effect is something that's especially prominent when mountains are found near the coast, but can happen with any range of mountains. We can see in this diagram here, the water that's blowing in off the ocean here is especially warm and is especially moist because it has a lot of water vapor in it that is picked up from the ocean. That is going to lead to this windward side of the mountain, or the side that is facing the ocean, to receive a lot of rainfall. That is because as this warm and moist air mass hits the mountain, it starts to rise. That causes the air mass to cool, which means that the water vapor in that air has to condense and fall as rain. So on the windward side of the mountain, we get very lush green vegetation. On the other side of the mountain, though, which we call the leeward side, is very dry because the air has lost most of its moisture on the windward side of the mountain. This dry air that is descending down will form desert-like conditions on the leeward side of the mountain, which is the side that is facing away from the wind. Again, this is most prominent close to the ocean, but this can happen effectively with any range of mountains. Let's take a look at a real example of the rain shadow here. In South America, we have the Andes Mountains, which is this long, narrow coastal mountain range that we see shaded on the side of the map. And to understand the rain shadow effect here, we need to remember that the prevailing winds between 30 and 0 degrees, or between 30 degrees and the equator, are going to be from east to west. So if you notice, the arrow here is indicating the direction of our winds, and what that means is that our eastern side of the Andes, the side facing the wind, is going to be the windward side, and this is going to receive this very moist air that has picked up a lot of moisture from the Atlantic Ocean. And what we are going to see on the windward side, or the side is facing the wind, we're going to see a lot more vegetation. If we were to draw in that vegetation, it might look like this in South America. as we're going to expect to see a lot more of this lush green rainforest area with high amounts of precipitation on the eastern side of the Andes, or on the windward side. But on the leeward side, or the side that faces away, we're going to expect to see a lot drier conditions. This helps us understand why the Atacama Desert, which is located on the western coast of South America here, is positioned where it is. This warm air mass that is moving westward across South America has picked up a lot of the moisture in the Atlantic Ocean, and it is depositing all of that moisture as rainfall on the windward side of the Andes. Once it rises up and over the Andes, the air has lost most of its water vapor, and it is descending down on the leeward side, causing the westward side as a really dry air mass that produces these arid desert-like conditions. Remember also that being at 30 degrees latitude also means that the conditions are going to be a lot drier because of the Hadley cell. This is where we get that air mass that's sinking back down to Earth, and it's very dry. And notice how close the Atacama Desert is to this 30 degrees south latitude. And that is also going to help us understand why there are such dry conditions there. Now, if we look at an aerial photo of the Atacama Desert here, we can actually see how dramatic this is when viewed from above. We can very closely follow that ridge here that has on the eastern side of the mountains the lush green vegetation from all the rainfall, and then the dry conditions on the leeward side or the west side. If we zoom out and look at all of South America, that rain shadow effect becomes even more dramatic, and we can follow the ridge of the Andes and again see that most of that rainfall is happening on the windward side of the mountains, and that the leeward side is far drier and obvious even from satellite images. When we look at an actual precipitation map of South America, this image on the left here that has all the different annual precipitation levels shaded in as different colors, we can see that the rain shadow effect is really, really pronounced. If we look at roughly where the Andes Mountains would fall, right along this region colored in red and orange, we can almost tell where the Andes are without even having them drawn in on the map. Because with the Andes here, we are seeing all this lush vegetation, this heavy rainfall on the eastern side of the mountains. This is the side that has that warm air mass with all the moisture coming across from the Atlantic Ocean, which we can see with the blue and green coloring. And then once it goes up and over the mountains, it is descending down onto the leeward side, and it's very dry. That is where we see these reds and these oranges and the really low precipitation levels. We can also see the impact that the tectonic plate boundaries have on the climate of South America. If we look to the right diagram, at this location of the subduction plate boundary along the coast of South America, that is actually what is responsible for forming the Andes. When we think back to our topic 4.1, we remember that the more dense oceanic plate is going to be subducted and forced beneath a less dense continental plate. When the oceanic plate subducts, the continental plate is going to force up some magma and some lithosphere upwards, which is actually what forms that narrow band of coastal mountains, which in this case are the Andes. Our science skill for practice FRQ 4.8 today is to explain how environmental concepts and processes represented visually relate to broader environmental issues. I want you to see if you can describe the regional precipitation pattern you would expect to see from the portion of Mexico and Central America indicated on the map, and then justify your answer. For a hint, think about the prevailing wind directions and the local bodies of water nearby this area, and try to decide what that would mean for the precipitation patterns of this region. Another hint to help you figure out this FRQ is to draw the equator and the 30-degree north latitude lines. This will help you in noticing where drier areas of the map should occur due to the Hadley cell. And remember that winds north of the equator are also going to blow from west to east. To those of you that would like 5 points extra credit, find a meme that has to do with one of the following topics and email it to me by midnight on August 31st. The topics are soil, soil formation, weather, or seasons. It must be applicable to apes, and you get double the points if it includes Indianapolis in it. Happy hunting! I can't wait to see what you create or find.